presentation of the final course project of CSCI 4050U for group number 12. This is Bushra and I'm doing the voiceover on behalf of my team. Our final project is called Brain Tumor Detection Using Transfer Learning. The goal of our project is to detect whether an MRI scan contains a brain tumor using deep learning. The learning problem we are solving in this project is brain tumor detection from MRI images. The input to the model is a single 2D grayscale MRI slice in JPEG or PNG format. These scans typically show the internal structure of the brain and tumors, which often appear as bright, irregular regions. The task is a supervised binary image classification problem, and the output of the model is a binary label where 1 means tumor detected and 0 means no tumor detected. The overall goal of the learning problem is to learn a function where fx tends to 0, 1, where x is an MRI image and the model predicts whether or not the image contains a tumor. The model must generalize well so it can correctly classify MRI scans so it has never seen before. This problem is important because early tumor detection plays a critical role in clinical diagnosis. While our project is only for educational purposes, a system like this can definitely help support radiologists and the medical world in the future. The dataset we used for our project comes from Kaggle, and it's called Brain MRI Images for Brain Tumor Detection. It contains a total of 253 images. Out of those, 155 images are tumor cases and 98 are non-tumor. All the images are 2D grayscale MRI slices, but they vary in size, so pre-processing was important. Here are a few sample images. You can see that tumor images show a bright, irregular mass with asymmetry in the brain structure. Non-tumor images look more uniform, without those bright abnormal regions. This dataset is relatively small, which is one of the challenges I address later. To prepare the images for training, we resized every MRI scan to 224 by 224 pixels, which matches the input size expected by Resident 18. We also applied image normalization, which helps the pre-trained model adapt accordingly to the new data. We used transfer learning because instead of using a CNN from scratch, we started with a pre-trained Resident 18 model that already understands basic visual features. We then replaced the final fully connected layer with a single output neuron so the model can perform binary classification, tumor or no tumor. Here you can see our training and validation curves. The loss decreases and accuracy increases without major signs of overfitting. When we evaluated the model on the test set, it achieved about 99% accuracy, with precision and recall both very close to 1. The confusion matrix shows that the model made very few mistakes on tumor versus non-tumor predictions. I'll be showing 2 big sections. Number 1 is going to be how to set up and run the application. And number 2 is going to be a live demo of the web application that we have built on tumor or no tumor results by testing on the MRI brain scan images that we have in our data. So right now I'm in my GitHub repo, and I'll be quickly downloading the zip folder and opening it up on my VS Code. Over here I have my terminal open, and I will be following the instructions in my GitHub's installation port to run it. So first and foremost, I will be creating and activating a virtual environment. I'll be copy pasting these things and pasting it here. Since venv has appeared at the base at the starting of my prompt here, so that means virtual environment has been created. Now I'll be installing the dependencies that I need for running this project. All the dependencies has been installed. Now I'll be running the Flask app. And this gave me a hyperlink that I will be opening up on my folder. And this loads the MRI brain tumor detector interface. So this interface is very simple. At the top, the user uploads and chooses an MRI image file. Then it clicks on Analyze Image. And then in the below part here, it will be displaying the selected image preview. The GradCam heatmap will be previewed and displayed, and the model's prediction, including confidence score and a short description of the model and the data set, will be displayed. Now I will be starting by choosing an MRI scan that contains a tumor. So I go to my test folder in ES files and I choose the first one. And an image has been reviewed, and now I click on analyze image. And that predicts a tumor detected with confidence level of about 99%. And over here, in the red yellow regions in the GradCam heat map, I can see it's very concentrated exactly over the bright circular mass, which is a tumor region. So this shows that model is not just guessing, it is actually focusing on the same area a radiologist would look at. Next, I will be testing the model with a non-tumor MRI image. And the non-tumor MRI image that I selected has been reviewed here, so I will be clicking on analyzing it. And it analyzed no tumor with very high confidence, close to 100%. And this GradCam visualization shows a very mostly dark blue with no strong hotspots, meaning the network does not find any suspicious region. So I can conclude by saying that this flash gap connects a trained ResNet 18 model to a simple user-friendly web interface. It allows a real MR tumor detection and also provides GradCam heat maps for transparency. In a real clinical setting, this kind of tool can be very helpful for decision support system for radiologists. But of course, in this project, it is strictly used for educational and demonstration purposes. So with that, I conclude my video presentation for the final course project of machine learning. Thank you.